So let's go over factoring trinomials, and we're going to do it two different ways. The first thing we have to realize is that this is in what's called standard form, okay? And we kind of have to define the coefficients with these variables or these letters we've used as variables because they'll help us organize our factoring. Okay, so this first term is the coefficient in front of the x squared is always called a. The coefficient in front of the just x variable is called b, and the constant term is called c. Is that familiar to you? Mm-hmm. Yeah. Okay, so here's our a value, here's our b value, and here's our c value. Okay. The first way we're going to do is called decomposition. Okay, this is very common, this style. And what we're going to be looking for is two numbers that multiply to what our a multiplied by our c is. So a times c. So we're actually going to have to figure out what those two values are. Those same two numbers have to add to what our b value is. Okay, so our b value. So in this case, and I'll just lay it out under here, our a times our c. Well, a is positive 12 and c is positive 12. So we have to multiply those two. So 12 by 12 is giving us 144. So we're looking for two numbers that multiply to 144. And those same two numbers need to add to our b value. And our b value here is negative 25. Okay, so we're looking for two numbers that do that. So I'm going to set it up underneath here. And usually the best way to go about this, they have to multiply to 144, and they got to add to negative 25. Now there are so many different numbers that can add and subtract to something. So let's kind of go through factors of 144. Okay, 1 times 144, obviously together, those aren't going to give us negative 25, right? 2 and 72, again, not negative 25. And let's think about this. These are all positive values, right? And this has to be negative. I know that I can multiply two negatives by each other and come out with a positive number. So secondly, both these numbers are probably going to need to be negative. So we have to use kind of some intuition there. I know another pair is 12 and 12, right? But 12 and 12 are close, or at least negative 12 and negative 12 are negative 24. That's not quite what we're looking for. Do you know any other factors? Maybe we'll have to jump through and test a bunch. 144. What other number would you like to try to divide into it? You can choose anything. We know that we went down the list. We did 1, we did 2, we did 12. So maybe try 6. 6 is 24, and 6 and 24, will that give us negative 25? No. Doesn't quite work. Okay, 144. 7, does that go in evenly? Nope, 144. 8, does that go in evenly? Oh yeah, 8 and 18. Do 8 and 18 do that? No, they go to 26. Okay, 144 divide 9. Oh, 9 and 16. What do 9 and 16 add up together? Do you know? Think about it for a second while I write it down.
Adding them?
Yeah, if we were to add negative 9 and negative 16. So negative 9 times negative 16.
25.
Yeah, there we go. So that's our pair. So we have to do a lot of trial and error, okay? So we found out what our pair is. Negative 9, negative 16 multiplied to positive 144, and they add up to negative 25. Amazing. So we have our new pair, okay? And sometimes that's a really hard process to start. What we do with that is we split our middle term, because technically this is negative 25x. Well, I know if I add negative 9x and negative 16x, I can build that. So we're going to decompose, and that's the idea here. We're called decomposition. So 12x squared is our a term. We keep the same. And I guess I'll rewrite it here so you can kind of see what our process is. I don't want to get you too confused. Y equals, we keep the 12 squared x. Here we're going to break our negative 25 into two terms. Negative 9x and negative 16x. Because together they make 25, but we're decomposing them. We're splitting them apart. And finally, the last term is positive 12. Okay. The next thing we're going to do is something called common factoring. And common factoring is where we take a term out of numbers, okay, a term that can be divided into everything. And we're going to common factor our first two terms and our second pair of terms separately. Okay, so I look for a greatest common factor of the numbers 12 and 9. So we got to think about what number divides into 12 and also divides into 9. Can you think of any number that does that?
3.
Yeah, 3. Perfect. Now the other thing with this is there's an x squared and an x. Well, that means I can also divide by x itself. Okay, so I'm going to divide the first pair of terms by our 3x, and our second pair of terms. Okay, we have negative 16 and 12. Can you think of a number that goes into 16 and goes into 12?
2.
2 does. There's actually an even bigger one. So let's try to see if we can come up with another one that does that. We know 3 doesn't. Doesn't go into 16 well.
4.
4, yeah. 4 goes into both. Okay, so we can divide both of these by 4. Okay, and there's no x to divide out, so we're only going to divide out 4. And as a hint for this process, we always want the first set of pair to probably be a positive term. So I'm actually going to divide out negative 4 each time. Okay, that's going to help us a lot in this process. So I'm common factoring. So I've divided both those terms. This should be. I'm dividing both those terms by our common factors. So we pull the common factor to the outside. 3x is what we common factored the first pair with. And that leaves us with 12 divided by 3. Well, that's 4. And x squared divided by x is just x. Okay. Negative 9 divided by 3 is negative 3. And x divided by x cancels out. So that's what would have been left after we divided those two terms by 3x. Okay. In our other pair, we took out negative 4. Negative 4 is our common factor. And negative 16 divide negative 4 is positive 4. And there's nothing to get rid of the x, so the x stays. And positive 12 divide negative 4 is negative 3. Okay? And what we're finding is you look at those two black brackets, they're the exact same. Okay, and that's our goal with the decomposition. We need these two brackets to be the same in order for it to work. So it worked. Our two brackets are the same, which is great because what that means is we can kind of, the idea is common factor the two brackets. Now that can be confusing because they're not single numbers, but the idea is we can now put that as the first set of brackets in our factored form. So it's our 4x minus 3. And our second set of brackets, I'll write it in red, okay, is actually going to be these two terms, the two common factors. So it becomes 3x minus 4. So the factored form, and I'm going to write this all in black now, y is equal to 4x minus 3 and 3x minus 4. That is the factored form of our original standard form. Okay, so usually we do expanding and simplifying to go from factored to standard. To go from standard to factored, we go through this long process of factoring. It's called decomposition. Okay.